Hi everyone, myself Bhagyashree, and today I'm going to solve one of the major problem which is asking many product based company. The problem is about the binary search related, and the question is here we can see maximum product of splitted binary tree. What is the question we have? The question we can go with the approach and what is the input we have and what we have to get the output. So the first of all the problem is given about the maximum product of the splitted binary tree. It means we have a splitted binary tree in the original tree, and in the original tree we have to split the binary tree into subtree, and basis on that we get the sum output, and what is the output we are getting in the subtree we have to be multiplied. Given the root of the binary tree, split the binary tree into two subtree by removing one edge such that the product of sum of the sum tree is maximized. We have to remove the one edge. Basis on that we get the two subtree, and on that two subtree we are getting the summation of that individually. One subtree have a sum, one another subtree have a sum, and what the sum we are getting we have to be get the summation. And finally our main intention is to get the maximized product or maximized value, I can say. And here the return maximum product of the sum of the two subtree. Since the answer may be too large, so return is modulo 10 raised to power 9 plus 7. So we have to be use this modulo operator. Because of that we don't get any overflow value. So this will be getting a constant, I can say, for multiplication after we are getting some integer or some value. So for that purpose it is given here, like this large return purpose, this modulo 10 raised to power 9 plus 10, 7 will be we have to be used. And second, the note that you need to maximize the answer before taking the mode and not after the taking it. Okay, so we don't have to like use the modulo operation without maximize the value. First we have to maximize, then we have to use the modulo operation. So the step modulo operation is using after the getting the maximum summation or maximum value after the splitting. So you can see in this input we have a one main root, and here we can see 2, 4, 5 is another subtree. Here I from this one we can see we are getting the another subtree. The subtree is means like the binary follow the root node left and right. Left should be always less than with the um root value, and right should be always greater than the root value. So basis on that we have to be select the node and split the tree. So if we cut this red edge, so you can see in the tree in the third node we have a left 1, right 6. Left is always should be less than with the original value or like node value, I can say. So that's why we are getting one subtree here, and 2 4 5 one subtree here. So basis on that we are getting two subtree after splitting, after like cutting this edge, and summation for this edge I can say 2 plus 4 plus 5 11, 1 plus 3 plus 6 equal to 10. So after this summation we have to be multiplied. 11 into 10 equal to 110. So remove the red and then get the two binary with the sum 11 and sum 10. Their product is 110. Okay, so this is the combination of 2 3 approach. We have to take the sum, then have to be multiply the summation what we are getting from the subtree. Okay, so this is the concept which we have to be get, which we have to be achieve. So first, what the modulo operation here given, we have to be initialize that variable for the mod operation purpose. So I will create the mod operation first, mod variable I can say, and for the maximize our product, I will create the one variable for the max product also. Initially I have this 0, and second I have to be use this max product, so it will be constant int mod the value 10 raised to power 9. 10 raised to power. Okay, So this will be our mod operation purpose. We are declaring the mod value. After this, we have to be, this is the global variable, so I have to create the after the function, like before the function, which will be access everywhere. Yeah, so coming to the max product, here we have to be, first operation I have to be bifurcate this two subtree, then get the sum, then getting the sum we have to be multiply. So we have to perform the three operation, and this is our main function, I can say, for the max product. Here we are returning our product value from this function. So I will just create total sum, calculate subtree, or better way name calculate subtree sum. It will be better to recognize. Yeah, and one function for the summation, one function for the max also. For the multiplication, I mean calculate max product, and after that we have to be written the value what we are getting from this max product. This value, sorry, we have to be use the modulo operation. That's why mod of. Okay, so we have to pass the root value. From this we have to perform the operation left, right, getting and all the stuff. And from max product we have to be use the root, and total sum what we are getting we have to be perform the multiplication of that sum. Okay, so first I have to create this function calculate subtree sum. Okay, okay, so for this sum what we have to first write base condition, because here we have to be perform this recursively. So that's why I have to write the base condition also for this one. So I have to check if node equal to 0, return what we have to be written, return 0, sorry, return 0. Where is my cursor? Yeah. Okay, so yeah, if node equal to null, then we have to return 0. Then we have to be take the left sum from this calculate subtree node dot left. Similarly for the right also. Okay, we are getting the left sum, right sum, and then we have to be add with the node value also, like root value also. So return node dot val plus left sum plus right sum. It is like we are using the pre-order format, I can say. Okay, so from this we are returning the sum. Then after that we have to calculate the product of this sum. So I have to create the function for this also. You can use a private, public. Most of the like private is using. So yeah, I will also use the private function. And here we have to be total sum. You can see we are passing the total sum also. That's why. Okay. So for the multiplication, what we have to be used? Again, we have to perform the base condition. Like because we are performing in the if this function is for the last binary tree, then it will be have to be very useful this recursive approach. That's why we are using this recursive approach for the summation for the product also. So I have to first base condition if root equal to null return 0. Okay, after that I have to be perform the left and right sum, left sum and right sum. In the left sum, same recursive I have to be used node comma sorry node dot left comma total sum. Okay, so we get the left sum and right sum, and finally I have to calculate the product of this current node, current sum I can say. Left sum plus right sum plus node dot value. This is the summation we till now we perform. We have to multiply this number summation. Like we have to multiply first binary tree sum and second binary tree sum. So we when we have a current binary tree sum and total binary tree sum, and for the other sum other binary sum or sub binary I can say um other tree, we can get the like minus from, like I can say if I have second like if I have a total 10 number, like total we have a 10 and I have first number 5, then second number we can get like from this p minus f, then what we are getting like this from 5. So this 5 into 5 we can perform, it will be getting the 25. So similarly this concept is also we are applying here for this multiplication of this sum of subtree. Okay, so I have to calculate the current sum, and I have to be calculate find out the second sum also, like second sum of the subtree. So I have to be minus. Okay, so I will directly do the product for how we getting the product current sum into total. Just I just explained that logic I am applying here. Current sum into total sum minus current sum. Okay, so it will be multiplying the summation of these two subtree value. Okay, and then after that we have to be perform the max product, which will be a max we have to be written. Compare between the current product what we are getting from the max product. Who will be a max that will be returning in this one. Yeah, let's run this problem. This code I can say. No does not exist. Sorry. Mix. I have to check for the null. This variable also. Line number 35. Oh, I use the node value. Oh, finally got it accepted. The logic is right, but yeah, some spelling mistake and correction we are doing. Okay, sorry for that. Yeah, so that is the approach for this problem. Hope you got the answer. Hope you got the idea about this problem. And yeah, last for this problem we had to be calculate the time complexity and space complexity. So for the time and space, I can say time complexity only big O of n, because it will be only iterating what is the number of nodes we have, and space complexity would be a number of edges, I can say height, big O of x. Thank you. Meet in the next video.